Good morning, dear students. In this session, we will talk about two-hinged stiffening girder solution procedure, how you solve two-hinged stiffening girders, and we will see an example also. Let us first discuss the difference in solution procedure between this three-hinged stiffening girder and two-hinged stiffening girder. Okay. So just if you just go back to the procedure that we have solved. So we have taken a three-hinged suspension girder where you have three unknowns. If you see the free body diagram of that, okay. So there are three unknowns. One is Q naught, another one is VA dash, another one is VB dash. Okay. There is a correction here. This is not 10. This is 20. Okay, please correct it. It is 20 meters. It is actually 20 meters, and in this it is shown as 10. It's 20 meters. Okay, right. So there are three unknowns: Q naught, VA dash, VB dash. There are three unknowns. You need three equations, right? Okay. So what are those three equations? Maybe sigma Fy0, sigma M0, and MC dash is equal to 0. Okay, so let us write them. So there are three equations: sigma m a dash or b dash equal to 0 is one equation. Maybe sigma Fy0 is another option. And finally, moment at c dash is equal to 0. So there are three equations and there are three unknowns. Three unknowns are what? Q naught and VA dash and VB dash. So you have three unknowns and three equations. So we are able to solve three-hinged stiffening girder. Now, if you have a two-hinged stiffening girder where there are only two hinges, no hinge in the middle. Okay, let us just take this, the girder, and you have no UDL from the suspenders all through this girder. Okay, so where we take this as Q naught is the value of UDL, what you are assuming it as Q naught. So same unknowns are present. This is A dash, B dash. So unknowns are not changed. But what happened? The equations have got reduced. So if you say two-hinged stiffening girder, in case of two-hinged stiffening girder, the equations have been cut down to 2. So now because of this, the two-hinged stiffening girder is indeterminate problem. So unknowns are 3, equations are 2. Okay. So then what you need to do to solve this two-hinged stiffening girder? So we need one extra equation or condition or assumption, anything which will help us to formulate one more equation plus 1 to solve these three unknowns. Okay. So what will be this one? This is important, right? So what will be that? The condition or equation or assumption. Okay. So that is what is the problem with this case. Okay. So let us come to see what is the condition, extra condition that is required here. So if there are only two hinges, then it will become indeterminate. Just now we have seen. So then actually the force in every cable can also be different, and that is the real problem for us. Okay. So what is the way that you are able to solve this one? So by assuming, please see this one, by assuming that the girder is very stiff, hence the load on the girder causes equal stress in the stiffeners, right? In the sense, uh, the assumption is the load on the girder is equally distributed to the suspenders. Okay, got my point. So if say there is a girder, a two hinged stiffening girder. Let us take the earlier example. Let us say this is like say 240 kilonewton. Let's say 300 kilonewton. Okay. Now to find Q naught. So now you don't have sufficient equations to solve for Q naught. So that's why we are assuming that the total load on the girder. What is total load on the girder? 240 plus 300. This is the total load on the girder, applied load. Okay. So 540 should be equally distributed to all these suspenders. So which means what? This is the load, so many kilonewtons, divided by the span, 120. Okay, so which will be equal to 4.5 kilonewton per meter. Okay, this meters. So 4.5 kilonewton meter is your equivalent UDL, what we call as equivalent UDL. This is what why we call W suffix E, equivalent UDL. So you don't need any equation, additional equation. So we are making one assumption, okay, so that you don't need to solve for Q naught by an additional equation. It is simply one assumption that the total load on the girder is to be equally distributed to all the stiffeners, irrespective of their internal force. Okay. So we assume that all the stiffeners will have 4.5 kilonewtons, right, in each of the stiffeners. Okay. So this is the assumption, right? In reality, it is not 4.5. Okay. Got it? So what you have is what you got the value. In the last case, we got 5 kilonewton per meter, right? Okay. So this is actual value. 5 kilonewton per meter is the one which you solved for a case of 3 hinged stiffening girder. Okay. So when it is 2 hinged, it is not going to be 5 because you are assuming that the total load acting on the girder is distributed equally throughout the stiffeners. Nothing but stiffeners are nothing but the suspenders. Okay, so that's why simple calculation. So to find Q naught is the notation we have used for 3 hinged girder. I'm using because that is not the actual value we are finding, so we are renaming it as equivalent UDL. Okay, equivalent UDL, equivalent Okay, UDL, equivalent UDL, right? So if you are solving for a two-hinged stiffening girder, find equivalent UDL from the equation total load acting on the girder divided by total span of the girder. And once you solve this equivalent UDL, then the remaining equations are available. Remaining unknowns you are able to solve with the no. Once you solve this one, now it is Q naught. Now became W suffix E. So you are able to solve this one just by calculating total load on the girder by span. So remaining you have two equations and two unknowns. So VA dash VB dash can be easily solved with these two equilibrium equations. So instead of this equation, now you have this equation for two hinged stiffening girders. Okay, this is the way we try to simplify the problem from indeterminate to determinate case by simple assumption that the total load acting on the girder is equally distributed to all the suspenders. Okay, so what is the equation form for it? W suffix E is equal to equivalent UDL is equal to total load on the girder divided by total span of the girder. Okay, right. We'll come back to the next session with an example. Right. Thank you.